Hello everyone, welcome to the video lecture series of course Internet of Things. In today's lecture, we are going to discuss topic Introduction to Hadoop. I am Professor Swati Suresh Pawar. Before starting with today's lecture content, let us revise the contents of the previous lecture. In previous lecture, we have studied Introduction to the Big Data, types of data, characteristics of big data, data handling technologies, flow of data acquisition, data storage. Now let us discuss the introduction to Hadoop. Hadoop is open source Java based framework used to store and process large amount of data. Hadoop framework is from Apache Foundation and open source means code is available for free and user can also change the code according to its requirement. That is, user wants to add certain functionality, then he can add it. Hadoop allows you to run your tasks on multiple nodes of clusters. Parallel processing is achieved with the help of Hadoop. Basic programming language for Hadoop is Java, but you can code it in any languages like C, C++, Perl, and Ruby. Hadoop can be used with standalone computer, but to achieve parallel processing, it should be used with cluster of machines. Hadoop has a master-slave architecture. There is one master node and number of slave nodes. Master node manages and monitors slave nodes. Slave nodes are responsible for performing actual tasks. Task is divided into number of tasks which is performed by these individual slave nodes and parallel processing is achieved. Figure shows the master-slave architecture of the Hadoop. Pillars of Hadoop. Following are three pillars of the Hadoop. Pillar of Hadoop, Hadoop distributed file system, MapReduce, YARN, Hadoop distributed file system. It is a pillar of Hadoop which is used for achieving fault tolerance and scalability. In HDFS, master node is called as name node where slave nodes are called as data nodes. In this file is divided into number of blocks and is sent to different nodes, that is data nodes. These blocks are again replicated to other nodes so that failure of any node can be recovered using these replicas. Name node has metadata, that is data about data regarding data nodes like block information, replica information, task given, etc. MapReduce. It is used for data processing purpose. It is working in stages. Mapping of task is done in this. Take the input convert cell of elements into multiple tuples. Reduce. These tuples are converted into smaller tuples for processing purpose. YARN. YARN stands for Yet Another Resource Negotiator. Managing resources is crucial task in big data. YARN is responsible for managing the resources efficiently. Characteristics of Hadoop: scalability, fault tolerance, reliability, open source. First is scalability. We can add number of nodes in cluster as per demand. Fault tolerance. If one node fails, then other node takes up the charge. Reliability. It is reliable to use. Parallel processing is achieved using cluster nodes. Open source. User can use and change the code easily. Now let us discuss the introduction to data analytics and its types. Data analytics is an art of analyzing data to convert information to knowledge. Data analytics is used to make better decisions in organization and in business. Useful patterns are discovered by analyzing raw data. Different companies in market use data analytics to increase revenue, to decrease cost of product and to increase productivity. Types of data analytics. Descriptive analytics, that means what is happening. Diagnostic analytics, what is it happening? Predictive analytics, what is likely to happen? Prescriptive analytics, what do I need to do? Descriptive analytics, this analysis is a study of what is happening in business or organization which depends on incoming data. Descriptive analysis is done with the help of reports, emails, statistics. It is based on live data. Descriptive analytics is first step of big data analytics chain. Example is annual profit or loss statement. Diagnostic analytics. This analysis includes study of why is it happening. In this stage, root cause analysis is done. In diagnostic analysis, historical data is analyzed to find root cause. Patterns and dependencies are identified at this stage. Organization does diagnostic analysis to find root cause of the problem as it gives deep insight for a problem. Predictive analytics. Predictive analytics refers to what is likely to be happen or what might happen. Predictive analytics is similar forecasting as we are predicting future at this stage. In this analysis, patterns, dependencies from history is used to predict result using some algorithm. It is used to predict future trends and to plan how these future trends can be used in organization for its development. Prescriptive analytics. This analysis is used to decide what action should be taken to increase profit and to minimize problems in the future. In this analysis, action, strategies to be followed and rules are decided. It includes recommendations for the future steps. Statistical models. A statistical model is a mathematical representation of how the data is generated for some sample data and alike data considering a large amount. In short, statistical model describe data generation process. Let's look what are various statistical models are used. Statistics means learning from data sets. Learning from data is done using statistical methods. Big data, sample data set values, statistic. A statistical model defines a set of probability distributions using which a data set can be tested. A statistical model tries to mathematically describe the data generation process using one or more random variable and few non-random variable as well. A statistical model is non-deterministic because of which some variables don't have a fixed value, but such variables have probability distribution which is used to determine its value. Statistical modeling has three main purposes: predictions, extraction of information, description of stochastic structures. Dimension of model. Consider a statistical model SP with P is equal to P suffix theta, where theta belongs to theta. If theta has a finite dimension, our model is said to be parametric. Mathematically, it can be represented as theta belongs to r raised to k, where k is positive integer and r is a set of real numbers. In this model, k represents the dimension. For example, a straight line has dimension 1. If we consider uniform Gaussian distribution where f, x, mu, a sigma square is equal to 1 upon root of 2 pi sigma square into e raised to minus x minus mu square divided by 2 sigma square, then dimension is equal to 2. If theta has a finite dimension, our model is said to be non-parametric. Parametric models are usually used in a practice. Nested models. Consider there are two separate statistical models and if first statistical model can be transformed into a second statistical model. Models by applying first statistical model's parameters, then the two statistical models are said to be nested. For example, zero mean Gaussian distribution is nested within all Gaussian distributions. A linear model is nested in quadratic model. Linear equation y is equal to b0 plus b1x plus epsilon, where epsilon belongs to n, 0 sigma square. Quadratic equation y is equal to b0 plus b1x plus b1x square epsilon, where epsilon is approximately equal to n0 sigma square. Comparing models. The process that generates the data considers that a true probability distribution underlying the observed data being generated. Model selection depends upon which elements of pair most likely to effectively estimate the true distribution. Exploratory data analysis, that is EDA, or confirmatory data analysis, that is CDA, can be used for comparing two models. In EDA, different variations of model is created and an evaluation is performed to check which one describes the data more fittingly. In CDA, a previously created model or models are compared with the data. Along with these models, base factor R2, the likelihood ratio test for comparing models. Analysis of variance. The term INNOVA was introduced in 1920 by Professor R. Fisher. It is used to test consistent difference between two or more means. Variance is measure of dispersion in dataset. It is used to measure how spread out data is. Analysis of variance is statistical tool of test of significance. Test of significance based on t-distribution is procedure for testing the significance of two sample means. For example, when three or more samples are to be considered at the same time, then alternative procedure is required for testing the hypothesis that all samples are drawn from same population, that is, these samples have the same mean. Basic purpose of INNOVA, that is INNOVA is to test homogeneity of several means. In this technique, total variation in data set is partitioned into several components. In INNOVA, we use F-ration test, which is used when following conditions are true. Independence case. Samples are selected randomly. There is no specific pattern while selecting their samples. Normality. Population from which the samples are taken considered as normally distributed. Homogeneity. It means variance between the groups should be same. Hypothesis testing. It is a method for testing an assumption about a parameter in population by using data measured in a sample. Hypothesis is checked by determining the probability that sample statistics can be selected if population parameter is true. Types of INNOVA: one-way analysis, two-way analysis, K-way analysis. First, one-way analysis. When comparison is to be done between more than three groups and only one comparison factor is selected, then it is said one-way analysis of variance. Two-way analysis. When comparison factor is 2 or more than 2, then it is said to be two-way analysis of variance. K-way analysis. K comparing factor are selected to compare means from distinct group, that is more than 3 groups. Then it is said as K-way analysis of variance. Mathematical explanation for INNOVA. X suffix ij is equal to x plus xi minus x plus xij minus x. This leads to xij is equal to mu plus epsilon ij plus alpha I, where mu is the grand mean, alpha I is the ith group mean, epsilon ij is the error term from a normal distribution. The null hypothesis of the test is that alpha 1 is equal to alpha 2 is equal to up to alpha k. In terms of computing the test statistic, we need to compute two values. Sum of square for between group difference, that is SSDB, equal to summation of I to k summation of j to n x bar suffix I bar minus x bar whole square. Sum of squares within a group. In this, individual mean is calculated first, then take deviation from individual mean. then square it and sum of all group is performed, which is represented mathematically as below. SSD suffix W is equal to summation of I to K, summation of Jn, x bar I suffix ij bar minus x bar suffix I bar whole square, where SSDB has a degree of freedom of k minus 1 and SSDW has a degree of freedom of n minus k. Then we can define the mean square difference for each metric. Ms suffix b is equal to SSDB divided by k minus 1. Ms suffix w is equal to SSDW divided by n minus 1. Finally, the test statistics in INNOVA is defined as the ratio of the above two quantities. That is F is equal to MSB divided by NSW, which follows a F distribution with K minus 1 and N minus K degrees of freedom. If null hypothesis is true, F would likely be close to 1. Otherwise, the between groups mean square MSB is likely to be large, which results in a large F value. Data dispersion. Dispersion refers to how data is scattered or dispersed. It is used to measure how the measurement value in distribution is different from specific value. When we have set of values, then we want to find how much values are varying from specific value. This is measured by dispersion. Dispersion of data can be measured in different ways. Ways to measure dispersion: range, variation ratio, mean deviation, and standard deviation. Data dispersion. Range. Difference between largest and smallest value in the data set gives us range of data set. That is, to calculate the range, we need two extreme boundaries values. Range is not concerned with middle values. Range of data set is equal to maximum value in data set minus minimum value in data set. Variation ratio. Variation ratio is used to calculate how much variation in the data set value are there from specific value. How low value of variation ratio indicates that data is less dispersed and is more concentrated. Where high value of variation ratio indicates data is distributed, that is VR is equal to 1 minus total data points in all categories. Mean deviation. It is used to calculate typical difference from mean. If data set values are close to mean, then value of mean deviation is very small. It means data is similar. Large mean deviation value indicates low similarity within the data. MD is equal to summation of mod of yi minus y dash divided by n0, where yi is set of data point values, y dash is mean values, and n0 is total data points. Standard deviation. It is used to calculate how each value is different from mean value in the data set. S is equal to square root of summation of xi minus x bar whole square divided by n, where S is standard deviation. Contingence and correlation. Contingence coefficient is used to tell whether two values in data sets are related or not, that is, two values are dependent or independent. C is equal to root of x square divided by n plus x square, where n is total number of observation and x is a chi-square strategy. It is statistical technique to show how variables are related to each other. That is, study of how variables are correlated is known as correlation analysis. For example, for example, height and weight of a person are correlated. Time and work done by a worker. There are three types of correlation: positive correlation, negative correlation, and no correlation. Positive correlation first. When relation between two variables is high, figure shows the positive correlation. Negative correlation. When relation between two variables is negative. No correlation. When there is no correlation between the two variables. Figure shows the negative correlation and another figure shows the no correlation. Regression analysis. Regression analysis includes techniques for analyzing trends between dependent variable and independent variable. Using regression analysis, user can make predictions outside given dataset. If prediction is within given dataset, then it is called as interpolation. If prediction is outside the range of given data, then it is called as extrapolation. By analyzing big data set using traditional approach, it's time consuming and there is burden while analyzing data because data set is too large. So for this purpose, regression analysis is used. In regression analysis, large data is divided in small data sets and then it is analyzed. In simple regression analysis, relation between dependent variable and independent variable is calculated. In multiple regression analysis, relation between dependent variable and two or more independent variable is calculated. In regression analysis, values are inferred based on some past value. Types of regression: linear regression, logistic regression, polynomial regression, stepwise regression, ridge regression. Linear regression. In linear regression, dependent variable is continuous, independent variables can be continuous or discrete. No of line is straight. In this relationship is between dependent variable and one more independent variable. Linear regression is represented by y is equal to a plus xb plus e, where a is intercept, b is slope of line, and e is the error term. Figure shows the linear regression. Logistic regression. Logistic regression is used to find probability for success and failure for an event. Logistic regression is used for dependent variable and this dependent variable is in the form of values, true and false. That is, it is used for binary values. Values is either 0 or 1. Odds is equal to probability of event occurrence divided by probability of non-event occurrence. Figure shows the logistic regression. Polynomial regression. Equation is said to be regression equation if power of independent variable is more than 1. Stepwise regression. This form of regression is used for multiple independent variable. Selection of independent variable is done using automatic procedure. Stepwise regression methods are as follow. Standard stepwise regression. It adds and removes predictors for each step. Backward stepwise regression. It starts with all predictors in model and removes the least significant variable for each step. Forward stepwise regression. It starts with selection of most significant predictor in model and adds variable for each step. Ridge regression. Ridge regression is used when independent variables are correlated. Precision and error limit. Accuracy is measurement of chosen to value, whereas precision is reproducibility of measurement. Precision is a degree of agreement among measurements which are obtained from measurement process being evaluated under prescribed conditions. Process stated must be in the state of statistical control. Repeated observation are key features of precision. In this, information cannot be taken from single measurement. Figure shows some sample results achieved for experiment. Now let us see precision and accuracy related to it. Here, center represents target value, that is true value. First shows the low accuracy and low precision. Second figure shows the low accuracy with a high precision. Third figure shows the high accuracy with low precision. And the last figure shows the high accuracy with a high precision. Figure A is neither precision nor accurate. Figure B is the precision but not accurate. It's precise but not accurate. Meaning of precise is which can be reproducible. Average result for figure C is accurate, but here precision is very poor. Figure explains both precision and accuracy are achieved. That is, goal is achieved in a figure D. Precision changes when process change. Because of change of operators, labs, equipment, precision may change. So effort should be made to minimize such changes. Following are some terms used in case of precision change. Repeatability. It is deal with variability between independent measurement results obtained within one lab by single operator. In this specific set of equipments are used. Reproducibility. It concerns with variability between single test results which are obtained using different measurement process, different operators, different labs. That is, reproducibility refers to obtaining results in different conditions such as labs, equipment process, operators, etc. Precision of a set of measurements. Data set of repetitive measurements contain mean or average, where y dash is a sum of individual measurement of yi divided by number of measurements n0. Y dash mean is equal to summation of yi divided by n0. Deviation from mean is a difference between individual experimental value and mean value. That is d is equal to yi minus y dash. Average deviation. Delta y dash is equal to summation of mod of yi minus y dash divided by n0. That is absolute value is taken. Errors. Difference between measurement and true value is generally referred as error. Even if experiments are planned meticulously and executed, still there are some errors in the results. Sometimes true value is unknown, so the errors are also unknowable. Limit to errors are deduced from precision and bounds on systematic errors, that is, on process from which errors has been occurred. There are three types of error in the observation while performing the experiments. Types of errors: random errors, systematic errors, gross errors. Random errors. These errors are caused by uncontrollable fluctuation in the R affected by such variables. Experimental result fluctuations. For example, air pressure during lab experiment. Negative and positive scattering of data is a key feature of random errors. Systematic errors. When limiting mean is not equal to true value, then these are type of systematic error. These types of error can have both variable and constant components. Known components can be eliminated and unknown variables should be identified. For detection of systematic errors, tools like control chart for process mean and process range are used. Gross error. Gross error are generally caused by failure of equipment. Summary of today's lecture. In today's lecture, we studied Introduction to Hadoop, Introduction to Data Analytics, Types of Data Analytics, Statistical Model, Analysis of Variance, Data Dispersion, Contingence and Correlation, Regression Analysis, Precision and Error Limits. Thank you.